Welcome to CE 405 Environmental Engineering 1 Module 5 Part 3. In this session, I am going to explain about the miscellaneous treatment used in water treatment process. In normal water treatment system, there will be a screening process. Then after that, the sedimentation process, and sedimentation come coagulation process, and the filtration process, and the last one is disinfection process. Depending upon the quality of water that we are taking from the raw water sources, that is surface water sources, we are providing the miscellaneous treatments. If any chemicals that cannot be removed from all these normal process are present in the raw water that we are taking from the surface water sources, then only we are providing these miscellaneous treatments. Then this is the list of miscellaneous treatment that we are usually use in water treatment system. The first one is water softening process. Second one is removal of color, odor and taste. Third one, removal of salt, that is desalination. The fourth one is fluoridation and defluoridation. First one, the water softening process. What is a water softening process? It is actually the removal of hardness from the raw water. And the hardnesses are classified in two types, that is the temporary hardness and the permanent hardness. Temporary hardness is caused by bicarbonates of calcium and magnesium. The permanent hardness is caused by chlorides and sulfates of calcium and magnesium. This temporary hardness can be removed by simply boiling the water. And the permanent hardness, we have to accept or adopt chemical processes like zeolite process, lime soda process, etc. The hardness is usually expressed in milligram per liter or ppm, that is parts per million of calcium carbonate present in water. The hardness of water is determined in laboratory by EDTA method. What is an EDTA method? It is ethylene diamine tetraacetic acid method. Generally, the hardness value should be in between 100 and 150 milligram per liter, which is desirable for drinking purpose. Then the effects of hardness, that is first one, the large soap consumption in washing and bathing, which is the major problem caused by hardness in water. And then fabrics will become damaged, that is when washed with this hard water, the fabrics will become rough and strained with the precipitates. And the hard water is not fit for industries like textiles, paper making, dye and ice cream manufacturers. The precipitates clog the pores in the skin and make the skin rough. It will produce the health effects also. And the precipitates can choke the pipelines and valves. That is, the hardness present in water will create the choking of the pipelines and the valves in the water distribution system. It forms scales in the boiler tubes. That in boiler tubes, that is present in the industry, it forms scales and it will affect the production and it will increase the cost of production. And very hard water is not palatable. That is, we cannot accept or drink the very hard water because of its taste difference. And when softening is practices, when hardness exceed 300 milligram per liter. When water hardness more than 600 milligram per liter, then we will reject the water for drinking purpose. So the water, the hardness present in water should be below 300. That is, desirable is 100 to 150 milligram per liter. And then the removal methods of hardness. There is temporary hardness and then the permanent hardness. And in temporary hardness, two methods are there, that is boiling and then addition of lime. And for removing the permanent hardness, there are three methods, that is lime soda process, zeolite process or base exchange process, then demineralization process. Then we will go through one by one. The first one is boiling, that is for removing the temporary hardness, which is caused by the bicarbonates of carbonates and bicarbonates of calcium and magnesium. Here the equation shows that the calcium bicarbonate, that is CaHCO3 twice, during the heating process it will converted into calcium carbonate and carbon dioxide and water. This calcium carbonate will be precipitated. And same happens in the case of magnesium bicarbonate, that is MgHCO3 twice. The second method for removing the temporary hardness is addition of lime. Lime is calcium hydroxide, that is CaOH twice. CaHCO3 twice, that is calcium bicarbonate, plus lime, that is CaOH twice, will produce the calcium carbonate and water. Same in the case of magnesium bicarbonate. This calcium carbonate can be easily removed from water. This is for removing the temporary hardness from water. First method is boiling. Second method is addition of lime. Then the removal of permanent hardness. The first process is lime soda process. In this method, the lime and sodium carbonate or soda ash are used for removing the permanent hardness. That is named as lime soda process. The lime is CaOH twice and soda is Na2SO3. Is added together or added separately. We can add it together or can be added separately. It will react with the calcium and magnesium salt. That is, the permanent hardness is caused by chlorides and sulfates of calcium and magnesium. And these calcium hydroxide and soda will react with the salt of calcium and magnesium to form a precipitate of calcium carbonate and magnesium hydroxide. And these precipitated can be sedimented out. The lime removes entire carbonate hardness from the water of both calcium and magnesium. And the lime react with the non-carbonate hardness of magnesium to convert into non-carbonate hardness of calcium. This we can see the equations in the next slide. And the soda removes the non-carbonate hardness of calcium. This can be explained by the chemical equations, that is chemical reactions. The first equation, we can see that the sulfate of magnesium, that is magnesium sulfate MgSO4, will react with the lime, that is calcium hydroxide, will give MgOH twice plus calcium sulfate, that is CaSO4. This CaSO4 react with the soda ash, that is Na2CO3, will produce calcium carbonate and Na2SO4. This calcium carbonate can be sedimented out. And the calcium chloride, that is the chloride present in water, reacts with the lime, CaOH twice, will give CaOH twice plus CaCl2. This you see as the same equation, but the exchange process will happen. The next equation, magnesium chloride reacts with the lime, give magnesium hydroxide plus calcium chloride. This calcium chloride will react with the soda ash and which will produce the calcium carbonate. This calcium carbonate can be sedimented out. The second equation, that is MgCl2 reacts with the soda ash Na2CO3, will give MgCO3 plus 2NaCl. This is the lime soda process, and the permanent hardness caused by the sulfates and chlorides of magnesium and calcium can be removed by this lime soda process. The second method is the zeolite process. These zeolites are the compounds of silicates of aluminum and sodium, and it is also called the cation exchange process. When zeolite is added to water, sodium ion of zeolite get replaced by calcium or magnesium. The chemical reaction involved are the zeolite is SiO2 L2O3 Na2O. This is the chemical representation of zeolite. And 2SiO2 L2O3 Na2O reacts with calcium bicarbonate, will give 2SiO2 Al2O3 CaO plus 2NaHCO3. This is the main exchange process is happening. And the second equation, you can see that 2SiO2 Al2O3 Na2O, that is reacts with the calcium sulfate, which will give the 2SiO2 Al2O3 CaO plus Na2SO4. The exchange process will happen, and the calcium and magnesium can be replaced by the sodium ions. And the third equation, that is 2SiO2 Al2O3 Na2O, that is the zeolite, reacts with the calcium chloride, which will give 2SiO2 Al2O3 CaO plus NaCl. And this zeolite can be regenerated by passing a concentrated solution of sodium chloride through the bed. This zeolite is actually a bed, and the water is passed through this zeolite bed, and the zeolite can be regenerated by passing sodium chloride through the bed. After a time consuming process of this zeolite process, all the zeolite ions will be converted as that is the ion exchange process happens, and calcium or magnesium is replaced by this calcium or magnesium replaces the sodium ion, and this can be replaced by adding sodium chloride into the through the bed. That is 2SiO2 L2O3 Na2O plus 2NaCl will give 2SiO2 L2O3 Na2O plus CaCl2. That is, there is a slight mistake, that is not Na2O, it is CaO. CaO plus 2NaCl gives 2SiO2 Al2O3 Na2O plus CaCl2. In the second equation, it is correct. 2SiO2 Al2O3 MgO plus NaCl gives 2SiO2 Al2O3 Na2O plus MgCl2. Thus, the zeolite can be regenerated by doing or by passing the solution of sodium chloride through the bed. This is the zeolite process. I hope you understood the session about this miscellaneous treatment, that is water softening process, that is the removal of hardness, and we will see in the next session. So take care. Thank you and bye-bye.